Hi students, in this video we are going to see about Flint's classification of computer architecture. So before that we must know what is the mean by computer architecture. The computer architecture is a set of rules and methods that describes the functionality, organization and implementation of a computer system. Say for example, you are going to build a house. To build a house, what is the first step? You will be designing the layout of your house. That is called as a blueprint. So this blueprint, according to the blueprint only you will be constructing your house. So this blueprint and layout of your house is designed as per your wish and as per your like. The same thing only we are going to apply here. So we are going to design one computer system. So this computer system, your own dedicated computer system. So this computer systems before going to develop this computer system, the layout of the computer should be designed. So this layout is called as a computer architecture. So what are the steps to be followed when you are going to develop a computer architecture? Means there is some designed set of rules and methods are there. So this set of rules and methods are called as computer architecture. Then what it describes? It automatically describes the functionality and organization of your computer. So this set of rules and methods are called as a computer architecture. With its basic, Flint is the author. He developed the types of computer architecture. So totally he derived the 4 different types of computer architecture based on instruction streams and data streams. So we know that the meaning of instruction streams and data streams. Instructions are some mnemonic codes. So that when you are going to write the program, that program will be converted into instructions. A set of instructions are called as a program. So this is according to the instruction streams and data streams. This Flint's author derived the type computer architecture is into 4 types. So what are those? Means SISD, SIMD, MISD, MIMD. So first type is SISD, single instruction single data. Then SIMD, single instruction multiple data. Then third one is a multiple instruction single data. And fourth one is multiple instruction multiple data. Let us see one by one. The first type is single instruction single data. It is very similar to uniprocessor system. So it is a very first traditional monoprocessor computer system. So when you can see the diagram in the right side. So IO device is the first interface. It is going to interact with your human and your computer. So from the input output devices, the input is given to control unit. Here CU is the control unit and P is processing element and M is memory. So this very similar to your uniprocessor, where only one processing element is there. The inputs will be given, fed from input devices. After processing, it will be stored in the memory. Then it will be returned back to the human with the help of output devices. So it is a very similar, it's a similar traditional approach of doing one computations in the computer. Then what is the second type? Single instruction multiple data. Here each instruction is executed in different set of data, where in the first type only one instruction is dedicated for one data. Here one instruction is capable of executing its different set of data by a different processor, because we need to execute a different set of data, we need separate processing elements. So this is depicted in the figure. So here we have one centralized control unit for processing each data element, set of data. We have a separate processing element. So these processing element having the connection with memory, because that data should be stored in a local memory. Here this M are considered as local memory. So for each processing unit, this memory will be allocated. So likewise this assembly is designed. So this kind of organization is called as single instruction multiple data. So where for each multiple data, one processing element along with memory is allocated. right? I hope you understand this type. We'll move on to the third type. So multiple instructions, single data. Here, so what is the difference means each processor executes a different sequence of execution instruction. Here multiple instructions are going to play with single data. We are having one set of data, but this data, that computation involves many instructions. So this kind of organization will not be possible in case of practical executions, because here memory is shared with all processing elements, because we need a processing element for each instruction. So this will be interlinked. So this kind of organization will never used in practical executions, but it is a proposed model. Then we move on to the fourth one, that is called as multiple instruction, multiple data stream. Then here each processor has a separate program. Here, what is the difference between the previous one and this one means, here each processor has a separate program, and this will be interlinked in a one internetworking devices, internetworking connection. So here when you see the diagram, memory, processing elements and control unit is a one set of assembly. Similarly, you will be having more set of assembly based on your number of programs, set of programs, and these set of assembly is interconnected using a interconnection network. Okay, so here memory, processing element and control unit is a separate assembly dedicated for doing a single instruction, and these collections of separate assembly is interconnected together, and they will be exchanging their data and instruction. That execution will be shared within their interconnected network. So this is called as multiple instruction and multiple data stream. This kind of organization will be very helpful in case of parallelized processing and vectorized processing. So in case of where it will be mainly used means in case of multi-programming and multitasking, this kind of multiple instruction and multiple data streams are very useful. Okay, so once again we will recall this first one. So first type of computer organization is single instruction, single data. Here it is very similar to uniprocessor, where you will be having only one IO devices, one controlling unit along with it local memory. In the second type, you will be having a separate memory processing element, but control unit is shared to everyone. And third type is where it's not easy to implement. Here you will be having only one centralized memory, where the control unit and processing elements are different, and those are shared with this local memory. And fourth type is very similar to parallelized computers. Here one set of assembly is dedicated for each instruction. So memory, processing element, control unit as a separate assembly is assigned. So these different kinds of separate assembly is interconnected using interconnection network. Yes, I hope you understand this concept of Flint's classification. I will catch you in the next video about next topic. Thank you.